Hello, everyone. This is Kyle Welch with RCR Wireless News. I want to thank everyone for attending today's webinar, LTE Unlicensed and License Assisted Access, what it is and why you should be using it, presented by Aricent. Our presenters today are Ashok Kumar, Assistant Vice President at Aricent, and Avijit Ghosh, Assistant Vice President at Aricent. Just a reminder to everyone in the audience that within 24 hours of this webinar, we will provide you with the link to the recording of today's webinar. At this time, I'd like to pass the presentation over to Avijit.
Thank you, Kyle, and welcome everyone to this webinar on using LTE in the unlicensed or license-exempt spectrum, which we do believe will be a new opportunity for the carriers worldwide. So, coming to my first slide here, operators everywhere, cellular operators that is, have the same set of challenges, same set of technical challenges, and they are that of coverage and that of capacity. Now, coverage has been something that operators know how to deal with well. Cellular networks of today are direct descendants of networks built for car phones 40 years ago, and coverage outdoors is what they excel at. But unfortunately, in their very own coverage, footprint backyards, in the indoors, they do face coverage problems. Deep indoors, deep inside commercial buildings and basements and so on. So coverage is still a bit of a problem. But other than coverage, there's also the question of capacity. Cellular networks typically in the old days were designed and built for voice calls. That has changed drastically over the last 10 years. And now with LTE, beaming as much bandwidth as you can ask for to the end user, the necessity for handling and providing more capacity is very important. And this topic today is mainly to address the capacity problem. Now, if you look at this picture here, on the top I have, right here, I have a little bar which shows, roughly speaking, the kind of time the average user spends where he spends his time. Now, a lot of time is spent at home. There is a large part that's also spent outside home in indoor and near indoor situations. And then there is a time we spend truly outside. Now, the ratio, as you can see, is the time we spend really outside is actually very little. In fact, statistics show that anything from 10 to 15% is as much as you can expect when you are truly outdoors. So when we are not outdoors, when you are indoors, we can be at home, we can be in workplaces, indoor public spaces, and even when you are outdoors, sometimes we're in dense outdoor spaces. Now, if you look at these here, when you're at home, when you're in workplace, when we're considering data communications, internet access, stuff like that, Wi-Fi, more or less today, is the incumbent there. That's the connectivity option of choice when you're at home. When you are, however, in indoor places, which is not the workplace or home, other options, the private Wi-Fi access is no longer available. So you then have the option of using cellular coverage from one of the carriers that serve your area, or you can use carrier Wi-Fi or something like that. Now, as I said, for the cellular operators, indoor coverage is an outside-in thing, so it might be weak indoors. Now, this can be addressed maybe with small cells, from inside-out small cell implementation in those indoor venues, or it can be handled with some kind of license-exempt solution, which may be Wi-Fi, maybe something else. And when we're talking license-exempt thing, since any other entity other than a regular cellular carrier can also play in that space, here we have a possibility of competition from a third party. Now, since it's now this space between workplaces, indoor public spaces, and dense outdoor spaces are up for the grabs, they're contestable, and this is a place where the conventional cellular operator and a possible third party service provider of some kind, in US, for instance, is the cable operators with their Wi-Fi hotspots, for instance, can also play. So this is contestable. And to stay alive here, a carrier needs as much capacity as possible. And to get capacity, you need spectrum, Licensed spectrum is expensive. We all know what kind of auctions have gone on in all countries of the world. So it's expensive. And license exempt spectrum is free to use. So that's obviously the main attraction of the license exempt spectrum. So these are the interesting parts of the license exempt spectrum. We have the 2.4 gigahertz spectrum, the 5 gigahertz spectrum, and the 60 gigahertz spectrum. The 2.4 gigahertz spectrum, around 80 megahertz of it, is the most commonly used bit of unlicensed spectrum. Everybody's smartphone supports it. 5 gigahertz is the next, and the place where it's, I wouldn't say the emerging space, it's already well established, but now high-end smartphones, medium to high-end smartphones support Wi-Fi in that particular band. And 60 gigahertz is the one that's truly upcoming. Phones supporting this particular band are expected to come out maybe next year. This is the Wi-Fi 802.11 AD standard, which will be supporting this. Now, license exempt spectrum has its own quirks. Now, first of all, the exact allocations of what's license exempt varies by country. And these are allowed by the regulators on the understanding that it will be kind of fairly shared out between all possible users who might want to use it. So there is almost always a power limitation. And the power limitation, it flows from guidance from the LTE-U. We see power EIRP, that is effective isotropic radiated power, is limited from anything from 4 watts down to maybe 25 milliwatts by different jurisdictions for different bands. There might be other limits based on what kind of antenna gain you're using. There will be other kinds of restrictions, such as you might be restricted to indoor only, or you might be restricted to not being able to change your antenna. You might be restricted to how the power is spread across the bandwidth. For instance, particularly in the 5 gigahertz space, where airport radar also works, weather radar at the airports work, there are restrictions that require the unlicensed data access to comply to regulations such as DFS, where you need to first listen to see if there's radar working on that band and hop away if it is. And finally, there are also fair sharing etiquettes that just that may be mandated by regulators, that kind of tries to ensure that everybody who's wanting to share it, plays fair. And the stuff like that, stuff like duty cycle, stuff like transmit power control, where you end up using just enough power for the communication to happen. And finally, LBT, listen before transmit, is something. These are the regulations that are very much there in the 5 gigahertz band. And last but not the least, receivers in this particular band, in these bands, must accept interference. That means they don't really have too many people to go and complain to if there is a lot of interference in there. Though, of course, there are normally safeguards against somebody maliciously damaging communication in this band. So these are the salient features of the license exempt band in general. But the most interesting bit of it is the 5 gigahertz band at this moment. That's because 2.4 is completely congested. We know all about it. 60 gigahertz is just coming up, and anyway, because of the physics of the thing, 60 gigahertz doesn't work beyond line of sight very well. The range is small. So the 5 gigahertz is the most interesting band. Now, there is a lot of variation. There is a lot of variation in the way this is allowed in different countries. As you can see here, the United States is probably the most progressive in this regard. In the United States, 4 watts of EIRP is allowed in a good segment of the band, here and here, and 1 watt is allowed in the other bits. Now, this little bit here, between 5350 to 5470, is therefore internationally allocated for Earth observation satellites. So the radio community is very sensitive about it. But even so, in the United States, there is a FCC study going on, and call for opinion and so on, to ensure how this can be used in some way for Wi-Fi, properly safeguarding everything else. Europe is also following in this. So with Europe, you can see there is a study going on. It's pretty much the same 2 ranges, both for the EOS and also for the part which is currently allocated for vehicular Wi-Fi and so on. China, India, these large parts are missing, and There is no allocation there. In Japan, roughly speaking, follows Europe. And Korea, which is a country with a huge amount of broadband penetration, as we all know, has, even then, they are behind US and EU in the stuff that's been opened up, though I would expect that once US provides the lead, they'll open up pretty quickly. But what we can see here is from the amount of the 4 watts, 1 watts, 800 milliwatt, 200 milliwatt, we are talking about small cell coverage here. We are definitely not talking macro cells. So there are 6 approaches that are possible to, 6 distinct approaches that are kind of authorized by the 3GPP, standardized by the 3GPP to allow cellular operators to access this unlicensed spectrum, the 5 GHz band. Okay, let me just go up a bit. And here in 3GPP, this whole band between 5150 to 5925 megahertz has been declared to be a TDD band 46. This is in preparation for using LTE in the unlicensed spectrum, what the stuff we're going to talk about. Back to this. So 6 approaches. Now, the one on the extreme left, where the UE basically uses Wi-Fi and gets offloaded to the internet, is the the story of the operators of the old who are not used to mobile data and just wanted it out of their system, out on the internet as quickly as possible. So this is not very important in today's scenario. But here we have eSAMOG, which is a way by which a mobile can connect to the mobile packet core. There is this system by which any UE coming in through any kind of Wi-Fi can go in through the enhanced packet data gateway to the enhanced packet core. Now, this may not sound very useful, but this is the backbone of what is called Wi-Fi calling, and that's been deployed. It's seeing deployment all over US and bits of Europe. Then we come to the more interesting bits of the more recent bits. We have these 2 approaches called LWIP and LWA. These are basically LTE over Wi-Fi approaches, where we use bits of the LTE stack, like here, LTE PDCP on a Wi-Fi stack. Here, we use IPsec over Wi-Fi to connect to the eNode bay. And finally, we have a scenario where we have full-blown LTE air interface, see here, LTE-Fi, on top of a unlicensed band. Now, all the other Wi-Fi supported bands will work on all the Wi-Fi, all the bands where Wi-Fi can work. The LTE over Wi-Fi bands will work only on the band on which 3GPP has defined for LTE-Us, and currently this is the 5 GHz band only. Going to the next slide, even when we consider LTE over and the unlicensed exempt spectrum, there are really 3 flavors. And the first of them, and probably the one that's going to become most important at the moment, is what's called license-assisted access. This is the formal 3GPP standardization of this particular feature. This uses carrier aggregation of an unlicensed frequency band in the band 46, as we mentioned before, with one primary licensed carrier frequency. That's going to be act as an anchor. And over that frequency, control signaling is going to be transferred. And also, considering that this is only defined for downlink at the moment, all uplink traffic will come over that. And also, stuff like voice over LTE will also go over the licensed band. And the unlicensed band will be mostly used for delivering, let's say, internet traffic. So this particular standardization uses the LBT rules, and therefore it is eligible for deployment everywhere in the world, including European Union and Japan. So I keep talking about LBT. So what is LBT? LBT is basically 2 things. It's a bit of a politeness protocol, which basically says that when I have anything to transmit, I sense the channel to figure out that it's free, and only then do I transmit. And once I start transmitting, I don't hog the channel forever. I do not transmit more than a particular quantum of time at one time. Now, that quantum in Japan, for instance, I can't exceed 4 milliseconds. In Europe, it's like 8 to 10 milliseconds, maybe a bit more, depending on what exactly you're doing. But that's in what LBT is in a nutshell. Other than this, there is the LTE unlicensed flavor of the thing. Now, this has been proposed by the LTE-U forum, which is a group of US carriers led by Verizon and also Qualcomm. Now, this was supposed to, this is supposed to work on a base, or on the foundation of the LTE definition before release 13. This also uses carrier aggregation of unlicensed frequency with an anchor, and it's also downlink only. In this regard, it's very similar to LAA, but it does not use listen before talk. What it does is, it scans the unlicensed band to find a free channel, and if it doesn't find one, it just uses one that is in use, but then it uses a carrier configurable on-off duty cycle on one of those channels. So that makes it immediately, it cannot be used in European Union and Japan, but on the face of it, it may be allowed in United States, China, India, Korea, markets where we do not need, it's not required to have listen before talk. So you can see, this means that it tries to address Wi-Fi networks that are already present in that part, because it will be to try, it's make an effort to avoid them. But once it is occupied a carrier, it does not really allow for other Wi-Fi networks that might want to join in after that. And finally, we have this thing called multifier, which is a standalone LTE in a licensed deployment with no anchor. This has been proposed by Qualcomm. There is a multifier alliance which supports this. We don't have any details of that. We'll probably hear about it more from Qualcomm in MWC this year. There's already an event announced, but it's probably, I mean, if all we hear about it is true, it is likely to compete head-to-head with Wi-Fi, because if this is the way it is, even private non-operator guys can employ it. So these are the three flavors of LTE over unlicensed spectrum. Before I hand it over to Ashok for the next part, there are some justifications I would like to give, some reasons, some answers to some questions about why do LTE over unlicensed spectrum at all, and why do it this particular way. So the first question I'd like to ask myself is, why aggregate at the eNode B at all? Why not deploy standalone in 5 GHz, like let's say multifier is going to do? Well, the answer seems to be that the quality of service, that's the carrier's reason for existence in the wireless broadband area, can be guaranteed by aggregating paths, different paths to the licensed and unlicensed spectrum. Example is this graphic I have of the licensed spectrum path appearing to be like a private road from one end, from the operator to the terminal, from the carrier to the terminal, and the unlicensed spectrum path can be considered to be like a public highway. It's a 4-lane public highway. Okay, so the operator has full control over the licensed road, private road, and it can, strictly schedule, the buses going over it, for instance. But while it can schedule its own buses over the unlicensed highway, it cannot ensure that there are no other traffic, no other cars that come in between those buses on the unlicensed, the public highway. So the eNode B, depending on what the public highway is like, can decide to put a part of its traffic over it when it needs more capacity. And it will normally put the best effort class, the internet traffic class, on the unlicensed highway. Normally, that's what we'd expect. So this is one thing. And the other thing it can do this way is to augment hotspots within macro cells. This would not be possible if we were doing standalone deployments, which will essentially be small cells, right? The next question I'll ask myself is, why use the LTE air interface? After all smartphones already have Wi-Fi, so why not use Wi-Fi in some way? Well, the reason here is that the carriers, they face a perception problem with Wi-Fi. The end users here are simply too familiar with Wi-Fi, and there are certain expectations that have developed. So one of the expectations is that the user expects, I, for instance, would like to control my own Wi-Fi radio. In my quick settings in Android or iOS or even Windows Phone, I have a button for turning it on or turning it off. So I might like to use it. But as we have seen from the place where we talk about the RAN aggregate using both the eNode B and the LTE licensed path and the unlicensed path, we see that the eNode B wants to really control this unlicensed spectrum, the Wi-Fi, to be able to deliver the right experience. Now, if the user objects to the radio being turned on or off, well, we can't do that. So this is one objection. And the second objection is that the end user has normally come to expect Wi-Fi to be free, or at least very cheap. At home, it's definitely free. When I'm in a cafe, it might be complimentary. In several of our hotspots, it'll be significantly cheaper. So I've come to expect Wi-Fi to be free. So I may not like it if I know that I'm getting charged for mobile data when, in fact, my traffic is coming to me over Wi-Fi. So a method of radio access that's not Wi-Fi but still on the license exempt spectrum will kind of sidestep these concerns, and that's one of the benefits, likely benefits, of wanting to deploy the LTE air interface over the 5 GHz band. So with this, I will have to hand it over. I'll now hand it over to Ashok. So I think before that there is a poll or something. So Kyle, please take over.
So yeah, everyone, we have a poll here. If you don't mind, just take some time and submit your answer. So the question is, which of the following LTE and licensed related areas is not part of the 3GPP standardization work? So it looks like 50% chose NOTA. Then we had LTE-U at 34%, LWA at 9%, and then LAA at 6%. Okay, Ashok, I'm going to hand it back over to you, and go ahead whenever you're ready.
Okay, welcome everyone. Now we'll do a deep dive into the two flavors of LTE unlicensed, primarily named as license assisted access and LTE-U. So the cellular operators have been using the Wi-Fi way of piping the data through the Wi-Fi access points for quite some time to offload the macro networks. But in that, for a single service, they were not able to share the data because that happens at the core network level, as Avijit pointed out earlier. And particularly indoors is a challenge. So because with the smartphones, the indoor consumption of data by cellular consumer is growing very rapid fast, and very large portion of this data consumption happens when the consumers are indoors. And consumers experience, many of the studies have indicated that consumer is not very happy when he's using certain types of applications indoors. So cellular operators find it difficult to provide large reliable capacity indoors using macro base stations. So they were looking for ways how to increase the capacity indoors at a reasonable price points and giving consumers very good experience indoors. So currently Wi-Fi is prevalent and most of the consumers switch to Wi-Fi to get a better indoor consumer experience. So many of the operators are looking for how to serve these users with a licensed exempt spectrum using the LTE mode. So one of the options are the things which made it possible using LTE advanced technology by virtue of this combining the traffic over licensed as well as unlicensed channels, because that is allowed by LTE advanced technology, and that too using a single radio type. Now we go to the next slide. So there are two flavors of LTE unlicensed, namely, as I stated, license assisted access and LTE-U. Both actually are used along with a licensed spectrum by an operators. The only difference between the two is one is being standardized by the 3GPP because this can be universally deployed. On the other hand, LTE-U is defined by LTE-U forum, which can only be deployed in those countries where listen before talk or LBT is not a requirement in the unlicensed band. Recently, very recently, 3GPP has published the first standard of license assisted access. And currently it is only restricted to be used in the downlink direction. The uplink portion of the unlicensed channel is left for future reasons. Later on, they also want to utilize the unlicensed spectrum for uplink traffic also. And the standards have made it clear that fair coexistence mechanisms are put in place, because there will be a lot of protest, or you can say a challenge to the usage of unlicensed channel if it does not give fair chance to the existing or the so-called future technologies who want to use the unlicensed spectrum. We go to the next slide. Next slide graphically shows you that currently it is used, unlicensed spectrum is used along with a licensed carrier, just like a supplemental downlink channel. One can view it like, instead of having one pipe carrying your downlink traffic, now you have two pipes carrying your downlink traffic. The other pipe is used when it is free. It is not permanently available for piping traffic to the smartphone or the mobile consumer device. Subsequently, maybe later releases, most likely release 14 of the 3GPP standards, you will also see that the unlicensed channel is also used for carrying traffic from the mobile device to the network in the uplink direction. Go to the next slide. So the LTE unlicensed makes it it becomes a special case of one of the features which is ported in LTE Advanced, which is called carrier aggregation. Carrier aggregation allows that the total band through which a particular user data is sent is bigger than the basic channel which is defined in LTE, which is 20 megahertz. So basically, by which I combine multiple channels, 20 megahertz plus 20 megahertz, make it 40 megahertz. So you can presume that your traffic, when it is being transmitted to a mobile phone, is going over a bigger channel. So carrier aggregation, there is a concept of primary cell and a secondary cell. So the unlicensed cell acts like the secondary cell, and the licensed cell acts as the primary cell. The user has to establish the connection using the primary cell, on which most of the signaling will happen, and the downlink, the traffic will be carried by both licensed and unlicensed channel. Currently, unlicensed will only carry the downlink data. Unlicensed channel is not always available, so clear channel assessment procedures as defined in the 3GPP standards will be applied. By virtue of this, one has to see the availability of this channel and only then transmit on this channel. Now we'll go to the next slide. It shows you pictorially that you have a licensed path, you have an unlicensed path. Primarily, it acts as the primary carrier. The unlicensed acts like the secondary carrier. Control and data happens, as well as uplink and downlink traffic happens over the primary carrier, which is your licensed carrier. The licensed carrier can operate either in FDD or TDD mode. On the other hand, the unlicensed currently, as stated, is only downlink supplemental, defined as a TDD band 46. The licensed part is appropriately shared among users based on the scheduling mechanism implemented in the eNodeB or LTE base station side, and the unlicensed part is opportunistically used based on the channel availability by other technologies. So there is a concept defined in the 3GP standard which allows the user to report the channel usage currently. So the mobile phones will actually report how much the channel is, unlicensed channel is being used currently. Now we'll go to the next slide, which is the slide which is taken from the 3GPP technical report, which defines certain scenarios where this type of technology unlicensed technology can be deployed. Either macro cell acts as an umbrella cell and there is a small cell indoor and they are aggregated together, which is unlikely scenario because this requires a very fast bandwidth connecting the small cell and the macro cell. The most probable scenario, which is the scenario 2, where you have a small cell deployed inside the buildings and the small cells are using both licensed as well as unlicensed carriers, making the indoor coverage really bandwidth really high. The capacity indoors becomes really high because you are exploiting unlicensed spectrum along with the licensed spectrum. The scenario 3 and scenario 4 are quite similar. In one case, you're using the same carrier along with the macro cell, whatever the used in the macro cell. In the other scenario, you're using a different carrier in the small cell, and so basically you use 2 licensed carriers in one case. In the other case, you use only 1 licensed carrier. The most probable scenario which we foresee is the scenario 2, which will be exploited by the operators initially. What are the alternatives? As Avijit stated in the beginning, LTE and Wi-Fi aggregation is an alternative solution to LTE unlicensed. So this allows that I don't make any changes to the existing Wi-Fi access points. I basically integrate the Wi-Fi access point as it is with the LTE. So basically, when a consumer activates a service, so the service data is actually sent via Wi-Fi as well as through LTE licensed band, and the user can, in the mobile device, can aggregate at its end. So this is possible and currently being looked at, but it has not been, the first standard has not come out. Only technical reports are available. The advantage of this solution is that this is backward compatible. In the existing devices, it is possible to be supported by a software upgrade. Another alternative to this is that I exploit the unlicensed exempt band using just like Wi-Fi access point, which is what we call is a standalone LTE unlicensed, which is something like you have an LTE access points, something just like Wi-Fi access points. So basically, this is currently being not standardized by the 3GPP, but there is an alliance which is doing it, and it is also called Multifier. Now we go to the next slide. So the LTE unlicensed has been studied by many 3GPP members, and they have been doing a lot of simulations, and over a period of time, they have come to the conclusion that this is an overall the spectrum, when LTE uses the Wi-Fi license exempt spectrum, it increases the spectral efficiency versus the Wi-Fi. Though it can be debated because the incumbent technologies currently say that unless you prove that you're using the unlicensed spectrum fairly, how you can say your usage is more spectrally fair. But there are multiple factors which contribute to the spectral efficiency of LTE, particularly the way radio interface or the air interface is defined for LTE. One is called, you have a robust forward error correction, you have hybrid ARQ, because the data transmission over the LTE system in general make sure that the interference coordination and avoidance takes place, which is not the case in Wi-Fi. Then I will be able to support mobility, which is inherently built into the LTE systems, versus Wi-Fi, because Wi-Fi inherently does not allow mobility. So basically, when I use LTE unlicensed along spectrum in the unlicensed, it will be able for the user to move from one base station to another base station with data continuity. The eNodeB can manage the traffic over the license as well as over the unlicensed carrier based on the channel uses of the unlicensed band, and because it's a single type of radio access technology, I can synchronize my carriers and the radio access network. Now we go to the next slide. So in the next slide, we'll show you some graphical results from one of the 3GPP members, which have shown that the performance of LTE unlicensed versus the incumbent technology, which is Wi-Fi. When you increase the traffic, LTE unlicensed performs better versus Wi-Fi. Then you will also see that when the number of users are increased using the unlicensed band, the degradation which happens for Wi-Fi versus LTE, you will see LTE performs better. As I stated earlier, there are many benefits of LTE unlicensed over Wi-Fi, but Wi-Fi is very pervasive in consumer devices, and there is a vast ecosystem which supports Wi-Fi. So end of the day, because for the LTE unlicensed to succeed, the ecosystem has to be built from the scratch, which is currently being very sparse or almost non-existent, you can say, means few chipsets available which support this type of system. These are also proof of concept type of chipsets, not generally available chipsets. Now we go to the next slide. This slide shows you the results or the simulation results carried by NTT Docomo. So here it is compared with Wi-Fi. So if you are using a Wi-Fi access point and LTE access point, and it presumes different ratio of the uses of the unlicensed carrier, so you will see that LTE unlicensed always performs better as and when the uses of the unlicensed channel is increased. So as and when you are increasing the traffic load, the degradation in Wi-Fi happens much faster versus LTE unlicensed. Now we go to the next slide. Next slide shows you that if two unlicensed Wi-Fi access points are working, and then it compares two LTE unlicensed small cells operating, and then it shows one Wi-Fi access point and one LTE small cell operating, the comparison. So you will again see that overall LTE unlicensed performs better. Again, these are simulation results, these are not real results, because the standard has just come out about a week back. So as the results have just come out and the 3GPP standard has been published, there are few changes, some of which were expected, but some more changes have come. So I will just state what are the changes. So the first release specification of the LTE unlicensed has been recently published. TDD band 46 has been assigned to the 5 GHz unlicensed spectrum. The maximum duration of transmission is restricted to 8 milliseconds in one bus. So whenever you find that the channel is free, you cannot transmit more than 8 milliseconds in one go. A new type of radio frame structure has been defined, which is called type 3, which is very similar to type 1, but it only exists in the downlink direction. There is no physical broadcast control channel transmission on the LTE unlicensed carrier. So basically, though the unlicensed cell or the carrier looks like a serving cell, but it does not transmit the physical broadcast channel. So it makes sure that no user can make this cell as a primary cell. Also, there are some changes with respect to the transmission of primary synchronization signal and secondary synchronization signals, which are to be transmitted on the licensed carrier. So the way they are transmitted on the unlicensed carrier, there is some change. Because the unlicensed carrier is not permanently transmitted, so how do you get the feedback on this carrier, how well the user is receiving? So there is also typically use the reference signal receive power or reference signal receive quality. On top of that, there's an additional measurement has been defined for unlicensed carrier, which is received signal strength indicator. Also, a new type of radio network temporary identifier has been defined, which is called CCRNTI. This actually is a mechanism to inform all the users for which the unlicensed carrier is going to be used for transmitting downlink transmission data, that in which subframes the physical downlink shared channel is transmitted. So basically, it is some sort of a mechanism to inform the users, okay, these are the subframes are going to be used for transmitting downlink supplemental channel. The difference between the normal subframe in LTE versus the LTE subframe is that in these subframes, the transmission may not always start from the beginning of the subframe. It can start somewhere middle of the subframe, and also the same is that the transmission can end anywhere within the subframe. Also, to implement this solution, I cannot apply this unlicensed for users or the terminals which don't support this capability. So a new capability indicator field has been added, which every UE will report whether it supports unlicensed band or not from the LTE unlicensed exempt perspective. Now we go to the next slide. So we have been working with one of our partner on this technology close to about 8 months back, and we have developed a solution which allows us to support both flavors of LTE unlicensed. The solution is currently being tested in our partner labs. We are starting the next phase of LTE unlicensed with our partner, which will make it fully compliant with the 3GPP standards. The earlier implementation is somewhat close to standards, but not fully aligned to the 3GPP standards. And there is an intention, Aricent also plans to support on other platforms with our partners based on the traction this technology takes in the marketplace. And we are also watching LWA, which is another alternative to LLA. And once the standards do come out, or and there are requirements from the market, we'll support that solution also. In summary, in the last slide, the LTE unlicensed provides spectrally efficient solution to meet the growing need of data consumption indoors. The advantage of this is it uses a single type of radio technology for both licensed and unlicensed carriers. Basically, this is just like a normal LTE carrier aggregation. The only happens is instead of aggregating two licensed carriers, I'm aggregating one licensed and one unlicensed carriers, but I'm using the same radio technology, which is not possible in any other alternative because you have to use two different type of radio technologies. And typically 3GPP, most of the times, any service they define using a single radio. The LTE unlicensed solution can also be implemented in new devices, while LWA solution can be supported in earlier devices also, but LTE unlicensed cannot be supported in the older devices. The devices have to be new. So basically, in one case, in the case of LWA, the ecosystem exists. So it is also backward compatible. On the other hand, in the case of LTE unlicensed case, the ecosystem has to be built. But because of the advantages, it is likely that it will succeed because there is a lot of traction from the operators worldwide to exploit this for providing quality of service to the indoor users. Thank you. If you have Kyle, now.
All right, yeah, thank you, Ashok, for that great presentation, both to Ashok and Avijit. So we'll get into some Q&A here. So if anyone has any questions, please submit that via the control panel, and we'll try and get to that. Before we do start the Q&A, back to the poll question, which of the following LTE unlicensed related areas is not part of the 3GPP standardization work? LTE-U actually is not part of the 3GPP standardization work. Okay, let's get into some questions. First one we had come in is, can you please talk about one or two use cases where LTE unlicensed will significantly benefit customers?
Well, I will take that, this Avijit here. So one possible application I can think of is probably just this webinar, for instance. Suppose we have a webinar, like Zoom is providing it here, and attendee can be anywhere in the world, sitting at an airport probably, with a phablet or a tablet. And there is a speech channel, there is the voice circuit. Now the voice circuit can be carried over the licensed part of the spectrum. It can travel in its own QoS tunnel all the way from the home network, maybe in the US, to the airport, maybe somewhere in Asia. And it would get delivered to the user in, it's in a quality of service control environment. Whereas, let's say, the slide transitions, the buffered streaming video, this kind of stuff could go, they're high volume but bursty and kind of best effort, and they can be delivered over the Wi-Fi channel. This is a typical case of use case where LTE-U could come in handy.
Okay, thanks. Next question, let's go to Ashok. Is MIMO supported on the, where'd it go? Is MIMO supported on the license exempt band? And if yes, the maximum number of layers?
Okay, the transmission modes, the first 3GPP standard does not allow transmission modes 5, 6, and 7 using the unlicensed band. All other transmission modes are supported.
Okay, thanks. Next question is, how do you see the adoption of this technology, such as LTE unlicensed, from OEM and CSP perspective?
I think that there's a lot of this technology has been supported by many of the OEMs as well as the CSPs, but the ecosystem isn't there because the standards have just come out. In my opinion, it will take maybe 2 to 3 quarters before the first deployment of this system takes place. But I think many operators worldwide are looking at it, and if it proves its benefits in real field scenarios, the likelihood of it succeeding are very high.
Okay, thanks. The next question I think is probably best for Avijit. The 3.5 gigahertz innovation band would seem to be attractive for LTE-U, as it is totally independent from existing 5 gigahertz Wi-Fi uses. What is your view of using the 3.5 gigahertz band?
I'm sorry, I was on mute. So you're referring to the 3.5 gigahertz CBRS band here. I do believe there is some regulation that states that whatever is used in this band has to be entirely within this band. So while stuff like multifier, which is a standalone deployment on this band, would be useful, LAA itself, which requires an anchor in the license band, there may be a regulatory barrier. But other than this, I mean, if this barrier weren't there, no problem. This should be usable.
Okay. Next question we had come in is, if carriers do LTE on free spectrums, do phone and tablets support these bands?
Yeah, I can take that as well. So not yet. Right now, there are no phones out in the market that do this. But Qualcomm, who is the big driver behind this move, Qualcomm's new chipset, I believe it's the 820 Snapdragon, has announced support for this, and I do believe some high-end smartphones coming out this year they are going to pick up this chipset. So I do expect Qualcomm to, some of these phones coming out this year to support it. Not yet, but soon.
Okay, great. The next question is probably best for Ashok. You recommend measuring RSSI for the LTE-U band. Why can't you measure RSRP and SINR like you do for licensed LTE bands?
No, actually, you also measure RSRP and RSRQ, but because all the subframes are not transmitted at any point in time, how many subframes will you transmitted? So because of this, there is a mechanism which has been defined along with RSRP and RSRQ, which is also measuring the RSSI. It's not only RSSI for LTE unlicensed.
Okay, thank you. Next question, what are some of the main components that make connecting to LTE-U spectrum possible?
It is to whom?
I guess either of you.
Main components means prime changes will come in the base station of the E node B and on the device side. So if we are talking about LAA or LTE-U, there will be changes because changes are to be implemented on the E node B side of the LTE base station. Similarly, there will be changes required on the device side. These are the two components which are to be changed. If you are looking at a lower layer levels, the layer 1, layer 2, the layer 3, some changes are required. When we say layer 2, it's the MAC. The layer 1, when we say it's the PHY layer, and the layer 3, which handles which basically tells the user what is the type of aggregation going to take place. And similarly, on the device side, there will be changes.
Okay, great. We had another question come up that seems to go well with that. So how do you ensure a healthy ecosystem of chipsets and E node B vendors participate in the new technology stream?
I think on the E node B side, because the chipset is not required, it's more supporting the RF band and the layer one and some software at the higher layer level. On the other side, because on the device side, typically these are supported by a chipset modem. So particularly there are Qualcomm definitely supports it. They have come out with a proof of concept or a early version of this technology modem which is supporting this technology. There are other vendors which are very close to it supporting it. But on the E node B side, you only need the RF support and the layer 1 support primarily to support this, because the rest is implementable in the software.
Okay, looks like we have time for a couple more questions here. So can LTE-U be used for a startup communication company or in an underdeveloped area where there are no providers?
I guess it can. I don't quite understand what it meant by used by a startup. Can a startup develop stuff for LTE-U? Most certainly they can. Can it be used in an area where there are no providers? I guess so, but I mean, if you are going to deploy it there, then why not deploy on licensed band? So it's not clear to me why when the licensed band's available, why wouldn't one deploy on the unlicensed band? So it's possible, but I don't see the point. Okay.
Next one, will FDD and TDD synchronization be used simultaneously for LTE-U and LTE LAA?
Sorry, can you repeat that question, please?
Yeah, sorry about that. Will FDD and TDD synchronization be used simultaneously for LTE-U and LTE LAA?
Yes,
Ashok.
the answer is yes.
Okay. And then finally, can a streaming business such as Netflix, can they run on the LTE-U spectrum?
Who can?
Like a media streaming company such as Netflix.
Well, if it's a buffered streaming like I mean, okay, I can think of YouTube, which uses buffered streaming. Yeah, of course it can run on LTE-U. If you are using real-time streaming, however, it's unlicensed, so it might not work too well.
Okay, great. That appears to be about all the time we have today. I want to thank everyone for attending today's webinar, LTE Unlicensed and License Assisted Access, what it is and why you should be using it, presented by Aricent. Again, our presenters today were Ashok Kumar, Assistant Vice President at Aricent, and Avijit Ghosh, also Assistant Vice President at Aricent. To Ashok and Avijit, thank you.
Thank you.
Thank you, guys.